going through this example, we said, first of all, we will just integrate the function between our limits in the knowledge that that will equal 1. So if you integrate the function, this is what you get. Substitute the 2 and the 0 in. When you put 0 in, you'll get nothing. You only get something from the 2. And you get this equation here. Let's call that one equation number 1. Now what we need to do is use this extra information here, where the expectation of x equals 1. The expectation of x is the integral of x times by the function between the limits equals 1. I would multiply the brackets out, then do the integration. We know it equals 1. Substitute the two limits in, and you get another equation involving a and b. We got equation 2. Then what you need to do is solve those two simultaneous equations. Now the calculators these days should be able to solve linear simultaneous equations for you. Should just be able to type them in, and you get the values of a and b being 3/2 and 3/4. What I would then do in the question is rewrite my function with those values plugged in. So there's my function with the a and the b plugged in. I have to work out the variance, which is the expectation of x squared, take away the expectation of x all squared. The expectation of x squared is the integral of x squared times by my function between the limits. I would multiply the brackets out. I would do the integration, substitute my limits in, which is what I've done over here, and you get a value out for the expectation of x squared. Remember, that's not the variance. For the variance, you need to take away the mean squared. Now they stated the mean in the question, the expectation of x was 1. So the variance is the expectation of x squared, take away the expectation of x squared, and we get a value of 0.2. The last part of the question, haven't gone through that yet, that will appear in a subsequent video.